Hello everyone, me and my friend is going to explain about the different type of single-phase induction motor based on the production of rotating magnetic flux. Basically, there are four types of single-phase induction motor based on the different method of production of rotating magnetic flux. They are speed-phase induction motor, capacitor start induction motor, capacitor start, capacitor run induction motor, and shaded pole induction motor. Before we go in detail with these four types, we have to know why we add auxiliary winding to a single-phase induction motor. This is because we know that single-phase induction motor are not self-starting motor. Therefore, we add an extra winding called auxiliary winding to a main winding, so that we have a two flux at phase difference to produce a rotating magnetic field. This rotating magnetic field induced an EMF in the rotor. This induced EMF produces a current in the rotor which opposes the curves, and hence the motor starts rotating. Going to the number 1, speed phase induction motor. This type of motor consists of two windings, main winding and starting winding, or we also call it as auxiliary winding. So let us consider IST be the current through the starting winding and IM be the current through the main winding. The auxiliary winding or starting winding carries a series resistance such that its impedance is highly resistive in nature. Therefore, the current IST current through starting winding and the voltage are in phase, whereas the main winding is inductive in nature. Therefore, the current IM lags voltage by angle. Thus, there exists a phase difference between these two currents, IST and IM. Hence, these two currents produce two fluxes at different phase. Therefore, this results in rotating magnetic field. Due to this, the starting torque, which acts only in one direction, is produced. The auxiliary winding also have a centrifugal switch here, as you can see in this figure. This, when the motors gather a speed up to 70 to 80 of the synchronized speed, the centrifugal switch it gets open, and the running condition auxiliary winding remains out of the circuit. Here, the centrifugal switch gets open and the starting winding or auxiliary winding is opened. Therefore, the motor only runs in the starter winding. Therefore, we can say that the starter winding is designed for a short time, whereas the main winding is designed for a continuous use. As we have seen earlier, the current IM and the IST are split from each other by some angle at the start. Therefore, the motor is called speed phase motor. Now going to the second type, which is capacitor start induction motors. Here the capacitor C is added to auxiliary winding in series. This capacitor causes the IST to lead by angle pi, and in the main winding the current IM lags the voltage by angle phi. Therefore, there exists a large phase difference between these two currents. Due to this phase difference, the torque is produced. And similarly, as I have explained earlier, the centrifugal switch gets open when the speed approaches to 70 to 80% of synchronized speed and the starting winding is out of the circuit. And the capacitor in this circuit the capacitor remains in the circuit only at the start, hence it's called capacitor start motor.
Third type, we have a capacitor start, capacitor run motor. So in this motor is similar to the capacitor start motor in working, except that the capacitor here is permanently connected to the induction motor. Since it is permanently connected to the motor, it is normally designed to give a good running performance, hence it has a high power factor. The direction of the rotation in both the types can be changed by interchanging the auxiliary winding and the main winding. Next type we have a shaded pole induction motor. In this In this type, the stator of this motor has a number of silent poles, and each pole is slotted at a distance of 1/3 from one of the each. A copper bar is fitted with the smaller part of the pole and is called a shading coil, and hence the part is called as a shaded pole. All the poles are provided with the exciting coils which are connected in series to the single phase supply. When we supply a single phase supply is fed to the exciting coils, adjacent poles have a magnetic field of opposite polarity. So most of the fluxes set up in the poles passes to the air gap from the unshaded portion. The remaining flux passes to the shaded portion. When it passes to the shaded portion, an EMF is induced in the shading coil, which in turn circulates a current through the coil. This current causes the flux in the shaded portion to lag from that of the flux from the unshaded portion. This results in the shift of the flux from the unshaded to the shaded portion. This effect produces a torque which rotates the rotor from the unshaded portion to the shaded portion. The starting torque produced is very less, and the reversal of the direction of the rotation of the motor is very difficult. Thank you.